Ventilation is one of the most fundamental aspects of building performance. It affects indoor air quality, thermal comfort, moisture control and energy use. But not all ventilation systems work the same way. In this video, we'll walk through the main types of ventilation systems, explain how they differ, and discuss where each approach is typically used. By the end, you'll have a much clearer understanding of how each system works and where it's best applied. At the highest level, ventilation systems can be grouped into four main categories: natural ventilation, mechanical ventilation, hybrid ventilation, and controlled ventilation. Let's go through each one step by step. Natural ventilation relies entirely on natural driving forces, such as wind pressure and buoyancy caused by temperature differences. Fresh air enters and exits a building through openings like windows, vents, or shafts, without the use of fans or mechanical equipment. When designed well, natural ventilation can provide good indoor air quality with very low energy use. However, its performance depends heavily on climate, weather conditions, building orientation, and occupant behavior. Because of this variability, natural ventilation is often supplemented by or combined with other systems. Mechanical ventilation uses fans and ductwork to move air into and out of a building in a controlled and predictable way. Within mechanical ventilation, there are three main system types. Exhaust ventilation systems remove air from the building using fans, creating a slight negative pressure indoors. As air is exhausted and the indoor pressure becomes slightly negative, fresh outdoor air enters through vents, openings, or infiltration paths in the building envelope, because it is essentially being pulled in. This approach is simple and cost-effective, and it is commonly used in residential buildings and wet rooms like bathrooms and kitchens. However, incoming air is not actively controlled or conditioned. Supply ventilation systems work in the opposite way. Fresh air is mechanically supplied into the building, creating a slight positive pressure. Stale air then leaves through exhaust vents or leakage paths, because it is essentially being pushed out. Because incoming air is actively supplied, it can be filtered, heated, or cooled before entering the space. This gives better control over indoor air quality, but requires careful design to avoid moisture or pressure-related issues. Balanced ventilation systems mechanically supply and exhaust air in roughly equal amounts. This creates a neutral pressure condition within the building and allows precise control over airflow paths. Balanced systems are commonly used in high-performance buildings because they offer consistent ventilation and good indoor air quality. Within balanced ventilation, two common configurations are HRV and ERV systems. In a heat recovery ventilation or HRV system, heat from the outgoing exhaust air is transferred to the incoming fresh air. This reduces heating demand in colder climates by recovering thermal energy that would otherwise be lost. The two air streams remain completely separate. Only sensible heat, which is the temperature energy, is exchanged, not moisture. Energy recovery ventilation, or ERV systems, go one step further. In addition to heat, ERVs also transfer latent heat, which is the moisture content between the outgoing and incoming air streams. This helps regulate indoor humidity levels and can improve comfort and efficiency in both cold and warm climates. Hybrid ventilation systems combine natural and mechanical ventilation. For example, a building may rely on natural ventilation when outdoor conditions are favorable and switch to mechanical ventilation when they are not. This approach aims to balance energy efficiency with reliability and comfort, using the best aspects of both strategies. Controlled ventilation refers to systems where airflow rates are adjusted based on measured conditions, such as occupancy, carbon dioxide levels, humidity, or time schedules. Instead of ventilating at a constant rate, the system responds dynamically to actual demand. This can significantly reduce energy use while maintaining good indoor air quality. Controlled ventilation is often used in combination with mechanical or hybrid systems. Ventilation systems can vary widely in complexity, energy use, and level of control, from purely natural strategies to fully balanced systems with heat or energy recovery. Each approach has strengths and limitations depending on climate, building type, and performance goals. Understanding these categories helps designers and engineers select the right ventilation strategy for both comfort and efficiency. If you enjoyed this video, give it a like. And if you want to learn more about building systems, comfort, and performance, subscribe to this channel. Stay informed, stay inspired. TimberTalk.